Good morning, students. In our third chapter, Atoms and Molecules, we'll discuss the laws of chemical combination. We already discussed substances are formed, compounds are formed by following a fixed ratio. Preparation of compound must always form a fixed ratio. See, we have the recipe of different food items, recipe of sambar, recipe of biryani, etc. We must follow those recipes to get the tasted curry or the food items. In the same style, compounds are formed by following fixed recipe, or the recipe in chemistry is modified as laws of chemical combination. By following these laws only, we can prepare new substances. Okay. So, I took some chalk powder and I took a cup of water. Okay. For example, 50 gram of chalk powder and 100 ml of water. Cleared? So, 50 plus 100, I have now 150 grams of the contents. I added this chalk powder into water, 100 ml water. Stirred well, waited for 10 minutes. Afterwards, again I weighed the component. I must expect 150 gram of the mixture or a solution. That is, I used 50 gram of chalk powder and 100 ml of water. I must get the same quantity, the same weight of the product. How much substances you used, you must expect the same weight after the chemical reaction. That is the first law, law of conservation of mass. If you select A gram of substance and B gram of another substance, after a reaction, I will get C gram and D grams of two substances. What is the law state? The law states that A plus B equal to C plus D. Laws of or law of conservation of mass. It states that mass can neither be created nor be destroyed. You can transform one form of a substance into another form, but you are not allowed to destroy substances. You could not create the substances. The weight has to be followed. First law of chemical combination, law of conservation of mass. Mass can neither be created nor destroyed in a chemical reaction. That is, during a chemical reaction, the sum of the masses of the reactants and that of products remain unchanged. What are the ingredients I used? They are called reactants. What are the substances I created newly? They are the products. Mass of reactants always equal to mass of products. That is the first law. Okay. Moving to the second law. Suppose I am planning to prepare water molecule. I need hydrogen and oxygen gas. Two gases when combined, water is available. Depends on the condition, water may be in the gaseous form, may be in the solid form, or may be in the liquid form. Anyhow, hydrogen plus oxygen, I will get water. Okay, one molecule of water is formed when two atoms of hydrogen combines with one atom of oxygen. That is H2 plus O2 equal to H2O. O2, I must balance the equation as 2H2 plus O2 equal to 2H2O. I must always follow the ratio 2 atoms of hydrogen and 1 atom of oxygen. The ratio is 2:1. If I am preparing water molecule in Payangadi or if the process conducts at America also, the ratio may be fixed 2:1. 2 atoms of hydrogen and 1 atom of oxygen. The ratio must be fixed. That is the second law, law of constant proportion. It states that in a chemical compound, the elements are always present in a definite proportion by mass. The elements are present in a definite proportion by mass. For example, water H2O always contains 2 atoms of hydrogen and 1 atom of oxygen. Another example, ammonia NH3. It always contains 1 atom of nitrogen and 3 atoms of hydrogen NH3. See the representation in the picture NH3. 1 nitrogen atom surrounded by 3 hydrogen atoms. Chemical compounds are formed by following a fixed ratio. Law of constant proportion, or it is also called as law of definite proportion. Okay, water molecule is formed when I select 2 hydrogen atoms and 1 oxygen atom. Okay, instead, if I select 2 hydrogen atoms and 2 oxygen atoms, I will get H2O2. He is not water. It is hydrogen peroxide. So, if I am aiming at preparation of water, I must always follow the ratio 2:1. 2 atoms of hydrogen and 1 atom of oxygen. If I change the ratio, the product is not water, something else. Okay, the second law, law of constant proportion. Definite proportion or constant proportion, conservation of mass, the two laws are urgently required in order to deal compound preparation, or the recipe of compound preparation is conducting by following the two laws. Law of conservation of mass and law of definite proportion or constant proportion. Expanding the two laws, we have a theory developed by John Dalton. Okay, Dalton's atomic theory. The theory is called John Dalton's atomic theory. It contains some important postulates or rules. What are they? One by one, we can have a look. First one, matter is made up of tiny particles called atoms. The first postulate or the first rule is definition of an atom. That is, matter is made up of tiny particles. The particles are called atoms. The word atoms derived from the term atomio, that means indivisible. Okay, and the second one, atoms are indivisible and cannot be created or destroyed in a chemical reaction. The third one, atoms of a given element are similar in mass and properties. For example, atom of hydrogen, atom of oxygen, they are similar in their properties. No difference exists between the properties. Okay. A participant, an element contains one atom, or may two atoms, or may 3 atoms, or may 4 atoms. Okay, element is made of 1 atom, 2 atoms, 3 atoms, 4 atoms, etc. What is the specific feature? The properties of these atoms are identical. There isn't any difference. And the next postulate, atoms of different elements have different masses and properties. H2 atom of hydrogen, O2 atoms of oxygen. The atoms of hydrogen and the atoms of oxygen have different masses and properties. They are not identical or they do not have similar properties. Atoms combine in a small whole number ratio to form compounds. It is the definition of compound. Compounds are formed when atoms combine in small ratios, fixed ratios. The last one, in a given compound, the relative number and kind of atoms are constant. For example, water is a compound, H2O. In it, the relative number and kind of atoms, hydrogen, the number of hydrogen and the number of oxygen are always constant. That is H2 and O. 2 atoms of hydrogen and 1 atom of oxygen. So these are the 6 important postulates in John Dalton's atomic theory. Postulates of atomic theory by John Dalton. 6 important postulates are there that defines atoms, compounds, preparation of elements, preparation of compounds, etc. Okay, once more revise the 6 postulates. Number 1, matter is made up of tiny particles called atoms. Second one, atoms are indivisible and cannot be created or destroyed in a chemical reaction. Third one, atoms of a given element are similar in mass and properties. Fourth one, atoms of different elements have different masses and properties. Fifth one, atoms combine in small whole number ratios to form compounds. And the last one, in a given compound, the relative number and kind of atoms are constant. So, the 3 important laws